Hey folks, welcome to another up-solving session by Codeforces tester Arpa and former contest coordinator for sure. I'm gonna show you today today's third division contest solutions, and as always we start from problem 8. In this problem, if the number of legs is odd, for sure there is no solution at all. Otherwise, divide the number of legs by 2. Now you can choose one pair of legs for chicken or 2 of them for a cow. So what we'll do is fixing the number of cows at the beginning, and then number of chickens will be determined. How many cows we can have? We can have 0, 1, 2, 3, up to n divided by 4. So there are n divided by 4 plus 1 options. And if n is odd, there is no answer. So here is my code. N divided by, if n modulo 2 is not 0, answer is 0. Otherwise, n divided by 4 plus 1. Another way to discover this was just looking at examples, like watching that 3 is 0. Like, for sure, you know that odd numbers are 0. Answer is 0 for that. But trying for 2, 4, 6, and 100, and you see that it's divided by 4 plus 1. I solve it using this way, not that way. I told you I generated the proof right now during recording video. That's about problem A. Let's go to problem B. Problem B. Unfortunately, at the beginning, I got this problem incorrectly. Let's solve problem B. At the beginning, I got this problem B incorrectly. Let me show you the standings. I solved A in 2 minutes. I solved B in 15 minutes, which is so much. I got this problem incorrectly, but what you need to understand is, okay, let me write. Okay, the answer is B1 plus B2 plus 2Bn minus 1, which means that A2 minus A1 plus A3 minus A2 plus at the end A n minus n A minus 1. And you can see that when you sum these numbers up, we can remove all this, and the remaining answer is this. So we want to minimize this. For that purpose, you can understand that we don't care about A2, A3, 2, An minus 1. That's it. We can set all of them to 0 because we want to have lexicographically the smallest answer. Then it's just a casework on A1 and An. If one of them has some value, we set the other one to that. If both of them, they don't have any value, we just set both of them to 0. That's it. Let me show my code. I start with reading the input. If last integer is minus 1, then if the first is minus 1 too, we set both of them to 0. Then otherwise I set last one to first one. Otherwise I set first one to last one. And finally I print the absolute value, absolute difference between these two. And finally I go print all the integers. That's it about problem B. After problem B, I thought a bit on problem C, and I found it not that easy. So I went to problem D, and eventually I found myself on problem F because D was easy version of F. So I went to problem F, and after some time I got back into problem C. So let me describe the easy version of C. And just a note on easy hard versions of problems. If you find yourself very good at some level, like for example, you usually solve up to problem E third division contest, you can, and you see, for example, you have some C1 and C2 easy and hard, for sure go for hard version. Don't stop at easy version. Just go directly for hard version. When you solve it, go for easy version too. But if you're someone sometimes solving C, sometimes not, for sure go first for easy and then for hard. So what I did was going for hard for sure, and then solving easy, like not solving, just submitting for easy. And that is not what you should always do, all of you. That was a note. Let's go to this problem. Problem C1. You should observe that last terms of game are much important than the first ones. Am I right? Like, You can think about it like, if I'm the last player who has a really chance to change the answer, I I will do it. I can do it. What I mean by real chance is sometimes it's your turn, but you have both ones or you have both zeros, so you can't do anything with that because it's already determined. But if you have 1, 0, 1, 1, you can do something. What? Try to think in this direction. Go think in this direction. And what you can find, what you can find is the tricky thing here is, follow me. Consider the case that they are all like we have some ones, zeros, A, B. Consider the case that XOR of all A's and B's is 0. It means that whatever you do, either both of the scores will be 0 and or both of them are 1. So you can't do anything actually. Like, it's tie and no one can change it. Okay? So what I say? Let me repeat what I say. If XOR of all A's and all B's are is 0, it's like if we XOR all A's and XOR of them with all B's, and it's 0. It means that no one can change the answer and answer is a short tie. That's it. Otherwise, who wins? Winner is the one who has turn in the last turn that we have 1, 1, and 1, 0. Because before that, the answer is all tie, for sure, because they're even, the XOR is now even. And at that point, he has chance to change the answer, to flip the answer in some way, and the next moves, they will not change anything. Because of that, you can find out that winner will be who has the last bit that is 1, 1, 1, 0. It's about C1. You can solve this problem like that. About C2, the story is somehow similar, but with a little difference. But if you're still here, why you don't like and subscribe to our channel, such that more people come and watch this tutorial, if you think it worth it. In C2, we'll go this in the same direction. We'll XOR all A's, B's together, see the answer. We will iterate over the answer from the highest bit to lowest bit. Maybe we just need to take care about the leftmost bit. Is that true? Because the bits left to that, they will do nothing because they are 0. Game will tie in that bits. Either both players will have that bit or both of them will not have that bit. So consider the leftmost bit. One of them is 1, one of them is 0. And simply take the last turn that there is a difference between them, like 1, 1, 1, 0, at that position, and you can find the winner. Let me show my code for C2. I'll go receiving A and B from input. Then I'll calculate XOR sum using function accumulate. I'll XOR everything. I'll XOR everything, like all of A, all of these. If XOR sum is 0, it's tie. That's it. Otherwise, I take the last bit, I mean the leftmost bit of XOR sum. You can do it using bit width. And I start from the last index and -1, and I go to left. And for sure, there is a bit that these two AI and BI has some difference in that bit, because if that was not there, this bit was not on, it was off. I XOR these two together, and I check if this bit is on. If it's on, I will go further and check whose turn is this and print his name or her name, print their name actually, and that's it. So that's it about problem C. Let's do problem D. Okay, what is the difference? Okay, you just need to print yes and no in problem D. Okay, let's think about what is the sufficient condition that we can make it 3 and when we can't make it 3. The answer here will be, we can't make a tree if and only if there is a prefix that all of its numbers are larger than the suffix. Like, we can partition the array into two parts. The first part are all greater than the last part. I mean, minimum of them is larger than maximum of them. You can make a tree in that case for sure. Why? Because there is no edge from this part to that part. That's it. You can check that easily, right? You can check this like just by making a partial mean from this side, partial max from that side. You can solve this problem. Problem D. But problem F is a bit different. We'll discuss that later. Problem E. Problem E. Actually, as I said, I went to problem F and then to problem C and then to problem yeah, you can see problem B, then to problem F, then to problem, yeah, F and D are the same. Like, I solved F and submitted the same code in D. And then I went back to C and then finally E. And E took me a lot of time because I was trying to doing something fancy like using randoms and all, but the answer is not that. The answer is just some construction. Very easy, very, very easy. Like, just come with a pattern. The thing is, this 6 misguides you. This will misguide. First, for sure, you had this idea of, like, let's say we can put all the numbers like 1, 2, 3, 4 as is, like sort permutation, sorted permutation. What is the problem? Even numbers are okay with each other. Like, if you start from any even number, that's okay because it will not be bad. That index will not be bad. But odd indices will be bad. Then what you should discover is having some good numbers and bad numbers between them is not a good idea. Why? Because if you do that, those bad numbers can make a bad index, and that is not acceptable for us. So what you can see is we can have good, bad, good, no, sorry, good, sorry, bad, good, bad, and so on. This is our pattern. Good, bad, good, bad, good, bad, something like that. By good, we mean that we are sure that these numbers are good together. Like, I mean, this and 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 also these two. All of them, all of good numbers are good with each other. I mean, like, we'll try to make a sequence that consists. First, we need to make a good sequence. What I mean by good sequence is every adjacent pair are not co-prime. Let's focus on this. Let's make a long enough good sequence. So we can. So first, you might think about even numbers, right? Even numbers like 2, 3. I'm sorry, 2, 4, 6. They are all good together, but they are not lengthy as we need. The length we need is something around 2/3 of n, and what we found is half of n. So we need something better. To do that, let's add 3. Like, let's say 2, 4, 6, 8, 10 even numbers. Then 3, not necessarily 6 because 6 is already there. 9, 15, like, let's say 21, and so on. This is a good sequence. I know that there is a bad pair in between. It doesn't matter. Like, we have 6 chances to miss. So let's miss 1. Length of this sequence is a number of integers who are at least even or divisible by 3, which is 1 divided by 2 plus 1 divided by 3 minus 1 divided by 6, which is fortunately exactly 2/3 of numbers. So that's it. What I do is going directly for that. First, I push all numbers that are even, then I go push numbers. I could write it like I plus equals 2, it's a vector, and here I plus equals 6. Then go for ands, and then go for bats. And then you can see that I'm doing like this. At every 3 number, I put a bad number, and after that, I put a good number. That's it. Yeah, just this, and I get AC. It took a lot of time to solve these problems, but for me, but finally solved. Let's dive into problem F. In problem F, what I'm gonna do is just improving the solution for problem T. Let's go backward. Consider consider an index. Consider a number. If this number is more than all numbers to its right, I need to keep it somewhere and try to connect it with others later. Otherwise, if I connect it to the greatest number to the right, I can make sure that it's now connected. But there is an issue. Consider this case. Let me visualize what I'm saying. It will help you a lot. Okay. Consider this case. Look, by writing elements like this is a very nice visualization. This is 1, this is 2, this is 4, this is 5, this is 6, this is 3. Okay? So, sorry if I want to write it precisely. It's like this. I visualized this permutation like this. This is a type of visualization that help you a lot of times. Like, you can see its benefit in a lot of problems. Okay? So let's visualize as I did. So this element, I don't have pointer. This element, it has actually no edges for sure, because it's larger than anyone else to its right. Same goes for this, same goes for this, same goes for this, right? But it's not the case for this. If I just connect it to the larger one, I miss my chance to do this, but I could. So I should do this. I should connect this with all elements to its right that are greater than it. That are greater than it. But there is an issue. Consider this permutation. In this permutation, I will connect everyone with everyone, which is not good. It's not a tree. So I want this to remain a tree, right? So I shouldn't connect it to all numbers greater than it to its left. So let me summarize what I said. First, I said that I will connect everyone with all of the elements to its right that are greater than it. Next, I said that it may make cycles. So let's not do that. In order not to make cycles, I need to avoid in order to avoid cycles, I should keep one representative from each component I made till now. And when I go further and further, make sure that I connect the new node to just representative of elements I can connect with. And finally, remove all that representatives and keep one again. What I mean is, consider they are all representatives of their columns, right? Because there is no other representative. There is no other node here. Consider I connected with these things. Now I need to remove 3 nodes out of these 4 and keep a representative. What do you think? Who is the best one to keep as representative? The best one is for sure this node. Why? Because it's the largest and it's more likely to get connected to other vertices. So what I will do is precisely what I'm gonna say. When I see a new node, I will let's go from right to left. When I see a node, if this is larger than anyone else to its right, just keep it as a representative, proceed to the next element. Otherwise, start connecting it with representatives that are larger than this element. Connect it with them and remove all elements that you connected together except the greatest one. That's the solution. You can use sit for that purpose. Also, you can use a stack because you can see that representatives are always decreasing. Why? Because consider there is a representative larger than another one like this. I will remove this for sure. I will keep this one. So they are non-decreasing as you can see here, okay? So I can use a stack. So let me show my code. Problem F. I solved this in, let's say, I think something like 10 minutes because after B I switched to C and after that I switched to F. Okay, let's go for checking its solution. Look, I just start reading the input, I get a stack, I define a vector for X, I go backward. If a stack is empty or I'm larger than anyone else in the stack, I push myself. Otherwise, keep the largest element in the stack and then start popping all elements and make new edges using my node. And finally, push back the big element again in order not to miss it because we need one representative per component. And finally, print the answer. That's it about problem F. Unfortunately, I was unable to get AC of problem G during the contest. I got AC after something like 10 minutes. The reason was I missed that it's asking to find the minimum number of operations and count the number of sequences that lead to this minimum number of operations. I was trying to count all of the possible options. And yeah, I was unable to solve it. Because and when I found that I was doing wrong, I solved this problem in 20 minutes. Let me describe the solution for this, but if you are under 1700, please leave the video immediately. It's not for you. I'm not trying to make you more likely and more attracted to see the remaining part of video. It will not help you folks, really. You should go solve easier problems and then go to this problem. For sure, I need to increase my watch time. Why should I tell you to leave my video? But I see that it's not good for you. It's not really good for you. Go solve easier problems, get stronger, come back to this problem. It's not for you. Okay, let's go to problem G. Okay, first let's find X, which is very easy. So how we can find X? There are a lot of ways. You can start with some this every single element, let's say one AI, double it until it exceeds BI and you will find X. X is the minimum of them. If you are nerd, you can divide BI by AI and then find the largest power of 2, which is less than or equal to this number. This is what I did. And then X is found. That's it. Otherwise, let's start by seeing how many. Okay, consider that I start this having those increases at the beginning. Like let's consider the option that we start with doubling, then adding, like the second type of operation always, and then the first type. Okay, if that's the case, number of operations I need to do on the ice element will be AI minus bi minus ai times 2 to the power of x. And let x be the minimum number of doubling operations, not operations, all of the operations. No, just doubling operations. This is the number of addings I need to do if I want to do all of them after the last doubling. But I shouldn't do that, right? I should try to do these doublings before, as much as possible earlier, right? So consider this to be mine x. So if so I will do mine x minus 1 to be mine x divided by 2, and then I will convert it to this modulo 2. Again, I will define mine x minus 2 to be mine x minus 1 divided by 2, and I will model it by 2. And I will continue until I define mine 0, which I can't do anything about that. Now, I exactly know for each element. So for sure you know that x can't go beyond logarithm of 10 to the power of, let's say, 6, right? 20. It can't go beyond that. Because of that, let's say these are my doubling actions. For each element, I know how many times I'm gonna do something here. Okay? For example, 3 times and 1 time here. If I know that, so for example, I know that I'm gonna do operation of type of first type 2 times on index 2, 1 time and at index 1, for example here. And then here, let's say 3 times on index 3, and here 1 time at index 4, 1 time at index 1, and so on. Now, what I need to do is finding how many ways are there to arrange this. This is a famous problem. Consider you have n types of balls. Each of them you have ai number of balls. AI number of balls of color I, and you want to find the number of different sequences you can make. The answer will be like this. There are 2 types of calculating answers for this problem. One is having sigma of a's factorial divided by a1 factorial, a2 factorial to an factorial. This is the first way to do that. Another way to do that is doing them one by one. Consider I've already put x number of them here, and I want to add ai. I will have ai from x plus ai choices. That's it. I can find how many ways are there to arrange each of them, and there are at most logarithm number of groups, and that's it. Anything remains in this problem? Yeah, something remains here. You might see this thing, and you might wonder why is this. This is here because if this can go very large. This can go very, very large. Like it can go up to something like 10 to the power of 11, which calculating C and R, I mean, is not that easy at that level. At that scale, like 10 to the power of 11. Because of that, they given modulo to 10 to the power of 6, which means that if this goes beyond 10 to the power of 6 plus 3, you can discard the extra at all. Okay, let me show you my code for problem G. It starts with my struct mod int, and then it continues with C, just with a little if that says that if n is larger than mod, return 0. This is my code. I receive A, and then B, I calculate X, I go find C and T, which at the beginning are all 0, then add X, that will be something I'll add to X, and then print the answer here. Then I have mine, which I start from mine x, mine 0 actually, in the reverse order I described. Don't be confused. I start from mine 0, which is bi minus ai multiplied by 2 to the power of x, and then I go from 0 to x. And if it's possible, I will put what I have to do here to the next turn in order to make it more efficient, to reduce number of turns I need to do something, and then do this. And then I will add these balls, and then I will choose my balls out of all balls, and I will multiply answer with that. And finally, I will add x, and finally, I will print. And that's it about problem G. Thank you for watching. Thank you for watching this video, this solving session. Please put your comments. If you think explanations was short, tell me. If you think they were long, very long, please tell me. If they were boring, for sure, tell me. If you need something more like describing codes more, or if you prefer the type of recording the virtual contest and you see that, please tell me. Feel free to tell me anything. Thank you for watching. Please like, subscribe. Thank you. Bye bye.